All right, so in this video, we are going to be solving rational expressions part 2. So this is the second video in the solving rational expressions. I guess it should be technically solving rational equations since we are solving them. So all of these you will see an equal sign. I just have some steps and just some reminders on here. Kind of a nice little summary of this section. If you have a fraction to a fraction, you're going to cross multiply, which I'm not going to do any specifically in this video. You can see some of those in part 1. We're going to focus mainly on this side if you have multiple fractions. Now I have a fraction plus a fraction equals a fraction, but that could be a fraction equals a fraction plus a whole number. If I really have any addition or subtraction signs on either side of the equal sign, I'm going to have to do this right-hand column. When it says note that if you have an x squared, you will need to factor, here are all your factoring techniques, the same ones that we've been talking about all semester. Also, don't forget that if a restriction and a solution are the same, you will throw out the solution. So with all of these, you have to check the restrictions in addition to solving for x. So let's jump in. Example 1 is one that's a little bit different than we've seen, and it says solve for the specified variable. So these are called literal equations, which means I don't have any numbers, I just have a bunch of variables. And so it works the same, but it looks a little different because it has a lot of letters and people tend to freak out. So the first step is still going to be to find the LCD. Now there's no restrictions because what you guys can't see, but the problem in Hawk says assume no denominator has a value of 0. So we don't have to worry about the restrictions, but I am going to find the LCD. And so I'm looking at all the denominators. I have x, a, and b. None of those denominators have anything in common. And so my LCD is going to be x times a times b, or x, a, b. Okay, so when I'm solving these, the specified variable I'm actually looking for is to solve for x. So that means I want to eventually end up with x equals. Now, before I can do any solving for x, I have to get rid of the x in the denominator. So just like we've seen in those steps up above, we're going to multiply every single top by the LCD. So I'm going to have x, a, b, x, a, b, x, a, b. So I multiplied the LCD on top of all of them. Now I can do some canceling. So if I'm canceling in this first fraction, the x's cancel and leave me with 1 times AB, which is just going to be AB. Carry down my sign. And then in the second fraction, I'm going to have the a's that will cancel and leave me with, let me highlight this, maybe easier, 1x times b. Here I had 1ab. So in that one, I just have xb, because 1 times x times b is just xb. Carry down my sign. And this one, the b's are going to cancel. And so here I'm just left with 1xa, which is the same thing as plus xa. All right, so now I've got all the x's on one side. And so because both of these terms have an x in common, I'm able to actually factor out an x from both of these. So that x that I highlighted in green, I'm going to bring it outside, which means that now I'll be left with b plus a, because I took out those x's and I rewrote it right here. So I'm left with b plus a equals a b. Now I'm still solving for x, so I have x times something. To get rid of x times something, I'm going to divide by that something on both sides, which is going to make these cancel on the right, b plus a, which will leave me with just a b over b plus a, and that will equal that variable x that I am solving for. Now, you may be tempted to want to cancel these a's and these b's, but I cannot do that because those are touching addition down on the bottom. And so my final answer would be AB over B plus A, or more commonly, we would write this as AB over A plus B, because we do want to typically keep those in alphabetical order. And so there would be your final answer for that one. All right, example 2. Here's our problem. 3 over 4x minus 4 over 7 equals 4 over 7x. And so I have multiple fractions. So the first thing that I'm looking for is the restrictions. And in Hawks, these will ask you as step 1, step 2. So I'm going to find the restrictions. The easiest thing to kind of think about is find the LCD and then set that equal to 0. Instead of setting every single denominator equal to 0, it's going to kind of eliminate all that steps and just put it all into one step with set the LCD equal to 0. So the first thing I'm going to find is the LCD, and then to find the restrictions, I'm going to set that equal to 0. So when I'm looking at my denominators, 2 of the denominators have an x in common, and so in my LCD, I only need one x, and then 2 of my denominators have a 7 in common. In my LCD, I only need 1 7. And then from the LCD, I am missing this 4. And so I'll have also a 4 in the LCD. And so my LCD is going to be 4 times 7 times x. Or you can write that as 28x. Whichever one. I typically tell students to leave it before you multiply because it's easier to cancel. If you leave it as 4 times 7x versus 28x, but really it's the same thing. So to find my LCD, I'm going to to find my restriction, I'm going to set the LCD equal to 0, 28x equals 0, and so I'll divide by 28, divide by 28, and get a restriction of x equals 0. And so I type that into step 1 in Hawks, and then I just kind of store that information until the very end. Part 2, or step 2 into Hawks, is going to be then to solve it. And so step 2 in the steps to solving these is going to be take your LCD and multiply it everything on top. So I'm going to multiply every top by 4 times 7 times x, 4 times 7 times x, 4 times 7 times x. And so I'm going to multiply all of these on top by the LCD. Now if I've done the correct LCD, then all of my denominators will cancel. And so I'm going to go through and just do a bunch of canceling. In this first fraction, the 4's are going to cancel and the x's cancel. And so I'm left with, on top, 3 times 7. So there I've got 21. Carry down my sign, minus. In the second fraction, my 7's are going to cancel and nothing else. So I'm left with 4 times 4 times x. And so that's going to give me 16x. Oops. Carry down my sign, equals. And then this last one, what's going to cancel? My 7 will cancel and my x will cancel. And so in this one, I'll be left with 4 times 4, or 16. So thankfully, this one doesn't give me any x squareds left. So now this is just step 3 to solve the equation. I don't have any distributing or like terms to combine, so I get to go straight to solving. I need to get the x's by itself, so I'm going to subtract 21 from both sides, which is going to give me an answer of -5 over there. And then on the left, I'll have -16x. I'm then going to divide both sides by -16 and have a final answer of that thing simplified down to 5/16. So that would be my final answer. I go back and I check because my solution and my restrictions are not the same. That is good. Now that doesn't mean it's right. That just means it's not I'm not going to throw out that answer. You could check these. It's not very ideal, but you can always check these by everywhere you see an X, you can plug in 5/16, and then this whole equation should be true. Not ideal, but it is how you could check these. All right, last example is going to be 2x over x minus 2 equals 2 plus 3 over x plus 1. And so with this problem, I chose this one because it looks a little different with this 2 in the middle. And so it's still going to be fractions being added together. It's still going to be 2 fractions or 3 fractions being added together. But right now this doesn't look like a fraction. And so I have to make it a fraction by putting an over 1 on the bottom. So with this, sorry about that. With the denominators, I'm going through, I'm going to find the LCD. And so my LCD is going to be the product of all of these denominators because they don't have anything in common initially. And so my LCD is going to be x plus 1 times x minus 2. And so we said in the last example, the easiest way to think about your restrictions is to think about setting the LCD equal to 0. So I've got x plus 1, x minus 2 equals 0. Set each one equal to 0 to solve this. And so I've got those two as my restriction. So I've got a restricted value at -1 and a restricted value at +2. So I'm going to store that information for later. Now what I'm going to do is, now that I've found my LCD, I'm going to take that LCD and I'm going to multiply every fraction on top by the LCD. So x plus 1, x minus 2, x plus 1, x minus 2, x plus 1, x minus 2. Now I'm going to go through and cancel. If I've done the LCD correctly, then all the denominators will go away. So in this very first fraction, my x minus 2's is going to cancel. And so I'll be left with 2x times x plus 1. Carry down my equal sign. In the second fraction, nothing's going to cancel because it's over 1. And so I'm still left with 2 times x plus 1, x minus 2. Carry down my sign. And then in the last one, the x plus 1's are going to cancel. And so I'll be left with 3 times x minus 2. And so now it's just a matter of simplifying to get rid of all the parentheses. So FOIL, combine like terms, distribute, all of that kind of stuff. And so I'm going to just spend some time working from left to right. This first one, I'm going to distribute. And so I've got 2x times x is going to give me 2x squared. And then 2x times 1. So I'll have 2x squared plus 2x. Carry down my sign. That's that first one. The next one, this one's actually going to look a little different. I have to FOIL this thing And then once I've FOILed, I need to distribute that 2. So we're going to work this off to the side. I've got 2 times x plus 1, x minus 2. So here's kind of my scratch work. I need to FOIL it first. And so first is going to give me x squared, outer negative 2x, inner x, and last negative 2. Combine up like terms. So I'm just doing normal FOIL. Now from here, I need to distribute that 2 after I've done all the FOILing. So I'm going to distribute that and get 2x squared minus 2x minus 4. And so that is what's going to go in place of all of that. So again, I FOILed this part first. And then once I had that all FOILed out, which was right here, then I distributed the 2. You cannot distribute the 2 until you have FOILed everything. And then the last one, I'm going to distribute that 3. And so very similar to the very first part, I'm going to distribute that and have 3x minus 6. And so I've got a bunch of like terms I need to combine. I'm going to worry about combining all the like terms on the right. There are no like terms on the left, so I'm going to combine up these on the right first, and then we will kind of talk about what we're going to do from here. So I've got a negative 2x and a positive 3. That's going to combine. Negative 2 plus 3 is going to give me a positive 1x. And then I also have negative 4 plus negative 6 is going to give me a negative 10. Carry everything else down. And now because I've seen an x squared term, so I see 2 of them, I've seen an x squared term, this is going to be kind of your alert that I probably need to factor. And if I'm going to factor, so I need to factor. If I need to factor, then I have to get the equation equal to 0. That was one thing we saw back in 13.7 with the factoring, that I have to get everything equal to 0. So I'm just going to move everything over to the left because the x squared terms are actually the same. And so I'm going to minus 2x squared minus 2x squared. Those are actually both going to cancel, which now makes my life a lot easier. So now I'm left with 2x equals x minus 10. Now the x squared terms have gone away, and so all that we said over here about needing to factor, I don't need to factor anymore. Now it's just a linear equation because the x squared terms ended up being the same and canceling. So I'm going to subtract x from both sides. Those will cancel. That will leave me with 1x on the left equals negative 10. And that is my final answer. So I will check that. When I look back at my restricted values were negative 1, positive 2, and I have a solution of negative 10. Because those are not the same, then I can say that negative 10 is my solution. And so I would type that in as my solution to negative 10. Again, you can check this. You could plug in everywhere you see an x. You could plug in a negative 10, and that would make your solution true if we got it correct.